I'd like to welcome you to session 3 of this GALA, which is titled Digitalization and Artificial Intelligence, Implications Challenging OSH. We have 3 distinguished speakers here, Mr. Panagiotis Kouderis, who is Corporate Health and Safety Environment Coordinator in Trans-Adriatic Pipeline, TAP, AG. We have Victor Bolbot, who is a postdoctoral researcher in marine technology, Department of Mechanical Engineering, NATO University. And we have Mr. Georgios Floridis, who is an HS officer in the Electricity Authority of Cyprus. Let's see about our session here. Digitalization and artificial intelligence. First of all, let me introduce myself. I'm Athanasios Bougas. I'm a software person. I'm not a health and safety person. I'm a software person. I am the head of software development in Sigma Information Systems, the company that belongs to Management Force Group, and we build software for health and safety sector. So we have started our company in about 2020, 3 years ago, but I have a long background in medical applications, in defense, and space applications. Now I'm devoted to health and safety. Let's see about our session here, digitalization and artificial intelligence. What is digitalization? Let's distinguish from digitization. When you have your organization processes and you're using technologies to just make them digital, the same processes, then you have digitization. When you use technology, software, and equipment to transfer your processes and make them better, so change them, go take the next steps, then you have digitalization. Okay, just a small distinction. And about artificial intelligence, what can we say? Right now, it's the next big thing in everything. Okay, everybody, I guess that everybody who uses technology has to do something, has started to look at artificial intelligence. We have those platforms now that have appeared, and I think that everybody can have a small sample of what artificial intelligence can do for us. So this technology, digitalization and artificial intelligence can be used some way for occupational health and safety. Okay, let's talk about some of experience gained so far with our speakers. And now let's start with Mr. Panagiotis Kouderis. Allow me, who's gonna talk about the TAP's experience. They have implemented an HSE software. So, Mr. Kouderis, the corporate HSE coordinator at TAP, the last 3.5 years with a demonstrated history of working in the wind and oil and gas industry, skilled in environment, health and safety, pipelines and management, and has a strong operations professional with a bachelor's degree focused in physics from University of Patras, ISO lead auditor. Mr. Kouderis, you can start. Thank you.
Thank you very much, Athanasios, and for the introduction, the personal introduction, but also the introduction of the topic. So we're going to discuss, I'm going to present you what we have done the last 3 years of the commercial operation of TAP in regards to the topic of the digitalization. So which means that we have established some TAP electronic tools, in order to manage the HSE aspects and impacts on our sites. I think that the entire industry is moving to the digitalization, not only because of the environmental impact that you can reduce, of course, under a paperless environment, but also we can find benefits from putting in force the digital tools, electronic tools, and adding extra barriers for avoiding injuries or incidents. So the electronic EHC tools that we have are summarized, the main ones, I would say, because there are a lot of them in place right now. The main ones is the agency management system, the Agora. It comes from the ancient word, Agora. The electronic permit to work, which is named MOGO, and the workforce management, the WFM, which is connected with the maintenance plan on our facilities. And let's start one by one. So first of all, the electronic permit to work. The TAP permit to work system is giving to the TAP organization full control of all our activities and the condition under which they are performed. This is happening in all our areas under TAP's responsibility. It is a very effective and flexible tool for widespread projects, such as pipeline, and it can be ensured that work is done safely and efficiently. Using an electronic permit to work system offers some crucial benefits over a paper system. So first of all, it is easier the management of permits by a group of staff, including the risk assessment. Then key persons have full visibility and are able to see the status of all permits. We have a better system control, for instance, upcoming expiration dates and potential works that conflict are automatically identified. So somehow you can understand if in an area you have a simultaneous operation and the system will not allow you to perform that activity that you want because there is another one that could have an impact. It gives you mobility and flexibility. Permit to work users can manage permits while on the move. There is more accurate compliance with health and safety. It is a more transparent system. And why is that? Because we have historical data. We can see who issued the permit, who modified the permit, who accepted and approved the permit. You have an increased functionality to manage work and risk. It is significantly easier and faster to use. Complex works that may require multiple permits can be grouped by the system, and you do not require several different papers on hand while you are going on site. No need for rewriting because you can duplicate permits when a permit needs to be reissued or extended. So which means that this week I had an activity for maintaining the gas coolers. The same one will continue next week. So I'm just duplicating the permit and I'm gaining time, but also I have the opportunity to review it and to refresh it in case of some extra things were popped up during the first week of implementation. And also you can easily find all your permits and all the necessary data that you need through the search functionalities that exist in the system. Another big advantage of the electronic permit work system compared to the paper one is the power to send information and to have interfaces with other tools, is the topic that we'll discuss further on. So this, along with the automated communication features, such as notifying people who need to be involved and providing a rapid route to the information they need to see, is a major benefit for work control. Through this tool, the TAP permit work system is going to be upgraded from operational adequacy to operational excellence. So within our permit work system, we have different roles and different types of permits. So TAP right now is issuing exclusively electronic permit work. The paper one will only be used as a backup in case that the electronic permit work system will not be operative. So we have 4 key roles and 2 secondary. The key roles is the applicant, the originator, so is the contractor that is going on site in order to perform an activity. We have the issuing authority, that is a TAP personnel that are issuing the permit after reviewing what the applicant has documented. We have the area authority, which is the field supervisor, This role can be covered either through the TAP or the main O&M contractors engineers, which means TAP and in Greece, for instance, DESFA. And we have the performing authority, which is again the TAP or main contractor or subcontractor personnel. So these are the four key roles, and the two secondary is the isolation authority whenever we have an isolation, and this is covered by TAP and main O&M contractor engineers, and the gas tester, which again, something that is covered by TAP and main O&M contractors. So in a summary, we have different roles with different responsibilities. Each role has a clear scope of what he can do and he is supposed to do. Also, this permit to work system is applied for any activity on site. So we do not have any activity without permit to work. And for this reason, we have divided the permit to work in system in different levels. So we have the level 0 is for very low risk activities. For instance, level 0 is when the security guards will need to do a site tour in our locations. Level 1 for low risk activities, sampling of something or a vibration test on something, on equipment. And level 2 is anything that is connected with our 8 golden rules of safety. So more specifically, we can say that any activity that is a cold work, a confined space, or a hot work with a potential fire or explosion risk, and works on energized systems that they need isolation, all of them are considered permit work level 2. What's the difference between them? Of course, the barriers that you have in place and the authorizations that you need. So the TAP electronic permit to work system is applied from 2020, initially in Greece, and then we moved to Albania and Italy. Currently, we have more than 450 active users, and we have issued more than 15,700 electronic permit to works, which means that we have a very good sample in order to understand if this has helped us or not, firstly. Secondly, during that period, several optimization and improvement waves have been completed after the experience that we had with the implementation of it on site. TAP, because it crosses along 3 countries and we have several sites that we need to manage and maintain, the system, it allows you to create different organizational units or sites within the system. So in Greece, we have the Kipi pipeline, the Kipi compressor station, Vistonida, Sidirokastro, Nea Messymvria, Ptolemaida. These are different districts that they have O&M centers. The same for Albania and Italy. And with that way, you can have a total control of all the permits along all your sites. The system is controlled both from desktop PCs, but also from tablets. So we are moving towards this traditional image that we have, that a foreman or a supervisor is having a folder with several documents inside the method statement, the risk assessment, the permit to work, the certificates of the employees, the licenses of the operators, etc. All of them right now are stored in a system. And all the TAP employees, but also the contractor employees, have a tablet that all the info are stored there. So the electronic permit, the MOGO system is also operative through the tablet, and they can have access to all that info directly from the tablet. This is the flow chart for how the system works. I will not enter into detail, but what I want to say here is that there is, behind this electronic permit to work system, there is, of course, a code that needs to be followed, and it cannot be breached, which means that we have the applicant that is requesting a permit. We have someone that is verifying the permit, which is the TAP personnel. And after the permit that is issued and accepted, we have the area authority that is confirming that everything is done according to the permit. So this is a live code, as you can see. It is different from the level 1 to level 2. Always when you move to the next step, either you are the applicant, so the contractor, or you are the TAP personnel that is accepting that, there is always a message that is popped up in order to declare that the work for which the permit to work was issued has been properly performed and all workforce has been withdrawn, and that the equipment, plant, and electrical apparatus affected by the work have been left in a safe and clean condition, which means that we are forcing those that are involved in that process to take the accountability and the responsibility of that, even if it is on electronic way. And of course, there is, as I mentioned at the beginning, there is always this historic chart about, of course, this is the dummy permit to work in the training environment. We can see all the steps that have been followed and by whom. Who has issued the permit, who has generated the permit, who has reviewed, accepted, etc. So this is very important always whenever you have to do with investigations. When something has happened, either an incident or a near miss, you can easily go through that history and find out what has happened and which was the contribution of each different role within the permit to work. So we have the level 1, which is the applicant and performing authority, the level 2 in the code, which is the issuing area and isolating authority, and the level 3, which is covered by the same roles. All the records are kept of the employees. Imagine that, as you can see in the screen, you can see the permit. So here we are putting some general info about them, where will be this area, which is the scope of this permit, which is the workforce that will be needed for that permit. Then we have the location, so we mark on a map where this activity is going to take place. This will help us also to understand, or if another permit is going to be requested, always in the system you can see live if there is an active permit at that stage, at that area, so the system will forbidden you to complete or to proceed with your permit because of the CMOPs. You have the risk assessment that you need to perform within the system. You have the supporting information, which are information related to the method statement that is needed, to any lifting plan that is needed, to any isolation plan that is needed, to any certificates of the equipment or the materials that are going to be used. All of them will need to be there. So the issuing authority, those persons that are going to assess, they need to have all that info in order to give the green light to the permit. So for each step, there is a unique icon, as you can see, but this is too technical and I don't believe that it is very supportive. This is the way that you can see the map and the permits that are ongoing or archived or closed or suspended. Or here in a summary, we can say that on the map, you can see the status of each different permit at real time. Of course, the different icon, the different color means something else about the status of the permit. But whenever a user is entering in the electronic permit to work system, this is the landing page. And this is the info that he can get from the minimal info that he can get from the map, and then he can go deeply on each icon and see exactly the info for each different permit. That's it for the MOGO, the electronic permit to work. Now we'll move to Agora, which is another HSE e-tool. It's the big brother of the health and safety environmental management system. So it is the primary tool that is used to monitor and control companies, main contractors and subcontractors' performance. Within the Agora, Agora, we have some modules. The modules are the incidents, the risk assessment, the contractors, the competence, the waste, and the action tracker. So what is happening here right now? So instead of having a paper system for the incident reporting, now we have transferred all this procedure in the electronic environment. The same applies for the risk assessment. As TAP, we have the facilities risk assessment for each different facility, and we have the job role risk assessment for each different job role within TAP organization. So all these have been transferred in electronic environment. The contractors module, which is very important, and I want to emphasize that. Why? Because contractors is the main hazard that a company could have when contractors will need to come on your work site and work and perform an activity. So whenever a contractor is importing in your activity, is importing an extra hazard. So the contractor's control is vital for ensuring that health and safety environmental mitigation measures are in place. So what includes the contractor's control, we will see later on, but imagine that each contractor will need to have access to Agora, will need to go through the system and register the company and register also the employee's information. The competence has to do with the competence and training matrix that TAP has developed, and all the information about the training and the competency of the employees are stored on this specific module. For the wastes, we have, as TAP, but I believe also many other companies, we have the Asia, that is the environmental requirements that we have, environmental and social requirements that we have to follow during the operation phase. And some of them are related with the environmental monitoring services, environmental monitoring plans that we need to have in place regarding the air quality, regarding the stormwater, regarding the groundwater, regarding the wastewater, regarding the noise, regarding the lighting. So for all these different aspects, TAP needs to have an environmental monitoring plan through a specialized and certified contractors, which they will report us, which are the results of these campaigns. And these results will be stored in this electronic system. And whenever there is a deviation from the thresholds that have been sent through the ASIA, automatically the system will generate an action, which is linked with the next and last module, which is the action tracker, where the action tracker is linked with all the other modules that they can raise an action. The incidents, of course, they will have some actions from the incident reporting. So this automatically will be linked and generated to the action tracker module. The same applies to the risk assessment. The same applies to the waste in case that we have any non-compliance with the parameters that have been set through the environmental, social, and impact assessment. So the purpose of this tool, in summary, is to reflect the specific QHSE aspects and risks in operations. In addition, Agora is considered a bank of all the information regarding the QHSE tool and provides the capability for several reports, statistics, etc. The contractors control module, and we will go through some of the modules. It is applicable for TAP contractors and subcontractors.
One more minute, Mr. Kuter, sorry.
Yes, I will go fast. Where they will need to register their company's details and the staff registration. All these will be, there is a specific standard process. They need to put their HSE plan method statement, the SDAs, any other legal requirements that are specified in each country. This will be evaluated by TAP, and then a provisional approval will be given, either approved or not approved. The same applies for the staff. They will need to submit, upload the personal declaration, the permit to work certificates, trainings, crane operator licenses, and several other documents which will be evaluated by TAP, and then we will consider as approved or not approved. And of course, the same applies for the training, the competency and the training, which is following the similar process. So right now, in order to close, we have registered 55 companies, 463 staff have been registered, and this is the way that the Agora deck is appearing in our screens regarding the company info, regarding the incident report and lesson learned, regarding the environment, and also the other modules. Last but not least, all these modules, they have an interference, which is very important, but also the different modules that I presented to you before have an interference. The MOGO, the Agora, and the WFM, which means that, this is how I'm going to close my presentation with an example. If we have an employee that wants to do an activity, this means that the WFM, the workforce management, will need to pick him up, which means that the Agora info that is feeding the WFM, it needs to give the green light to WFM that this person is approved. Then the WFM is picking that person for the maintenance activity, and then the WFM is giving the info to the electronic permit to work system for that activity that need to be performed. This is very key for our tools that we are using. That's from my side. Thank you, and I apologize if I consumed more time than it was needed.
Thank you very much, Mr. Koudeis, for this very interesting presentation of the way you have implemented the software to your organization. It's impressive the extent to which you have implemented the software looks impressive. Okay, that was very nice, and we'll have the opportunity to have some questions at the end of the session. Let's move on now to our second speaker, who is, let me know, Mr. Victor Bolbot, who will talk about autonomous ship safety. Dr. Victor Bolbot is a postdoc researcher at the Risks and Intelligence in Marine Systems Group at Aalto University, with a doctoral degree from the University of Glasgow, Scotland, and an MSc degree from the National Technical University of Athens, Greece. During his studies as a master and PhD student, Victor has received multiple awards for his outstanding performance from distinguished organizations. Victor's research interest focus on design, educational aspects, safety, and cybersecurity assurance of complex and autonomous marine systems. Mr. Bolbot, you can start. Thank you.
Thank you for this introduction. Good time of the day, ladies and gentlemen. My name is Victor, and as already referred, I'm gonna make my presentation about the autonomous ship safety. I think you can see it here on the screen. So today I will just briefly introduce my university that I currently work at, and then I will describe very, very briefly some of the autonomous ship projects before going to the meat of today's presentation, which is autonomous ship safety challenges and way to address them. So Aalto University has been established in 2010, and it's a result of merging of 3 different universities in Helsinki. The university has 6 different schools. School of Engineering is the one that I belong to. We have something around 12,000 students, 400 professors, 4,000 other faculty staff. The university is highly ranked. It belongs to the top 120 universities in the world, and it's the 2nd best university in Finland. The university is very international, and around 50% of academic faculty is coming from other countries than Finland. In our research group, we have 6 professors who work on different topics, and our university is considered belonging to the top 25 universities when it comes to the subject of marine technology. Now coming closer more into the topic of today's presentation, my research findings and my main point of presentations stem from these projects that are presented here. So I have worked on AutoShip project, which was related to the design of 2 autonomous ship vessels, one operating in North Sea and another operating in inland waterways in Belgian canals. I have also worked on a remote pilotage project, identification of educational needs in the context of autonomous shipping, and development of enabling technologies for autonomous ships. Currently, we work quite heavily on development of autonomous navigation system in icy conditions. And we developed for that purpose a 3D printed ship, which you can see here on the picture. I have been also involved in other projects on safety. So essentially, the points that I'm going to present and refer to, they will be based mostly on this project that I have worked on and on my cooperation with companies like ABB, Kongsberg, Rolls-Royce Marine on the topics of autonomous ships, but they mostly present my opinions on the topic. So why does the maritime industry so heavily concentrates and focuses on autonomous ships? There are quite strong financial incentive for that, because by removing the crew, we can reduce the operational cost for the ships in some specific cases. We have already a strong demographic pressure, so the world population is aging and the number of seafarers is reducing. This problem is especially strong in Japan, and the average year of the seafarers currently sailing on the Japanese ships is above 50. So that's why people are kind of very interested in autonomous technologies. Also, considering the recent very sad events in the East Europe, we can see that many of the Ukrainian and Russian seafarers who were sailing on the commercial ships, they are out of the market, which also creates a big pressure. We also have some very strong safety incentives, because by removing the crew, we essentially reduce the likelihood of the people drawing or having other accident fatalities on the ships. Something that came recently is related to COVID-19. Essentially, if we don't have any crew on the ships, then we don't have any extra quarantine requirements for the crew, and this facilitates strongly the maintenance and other activities on the ships. And it's also a matter of pride. Many nations, they want to demonstrate the technological power by using the autonomous ships. However, I would like to present these 4 points which I would emphasize during this presentation. Firstly, accidents are still anticipated to happen in autonomous ships, and I will explain the reasons why. And achieving safety, it can be a very big problem and obstacle to the autonomous ships adoption. And in some particular cases, safety demands might render the application of unmanned ships impossible. And if an accident finally happens, this will have a big impact and influence on the whole industry of autonomous ships. So what are the autonomous ship challenges? When people think about autonomous technology in general, they think that the accidents that we can have are something like that. So robots taking over and destroying the humanity. But in the reality, we have much more peculiar accidents of most probably of this type, or more sad, like this one, or this type of accident, or this type of accident. Currently, we don't have any officially reported accidents related to autonomous ships, although I'm aware of some small incidents. And the reason is that they're simply not widely used. But I would consider that accidents on autonomous ships are finally inevitable, because novel technology has always resulted into additional risks. And that's what the history of technology teaches us. When airplanes arrived, then the air crashes started happening. When the first steam engine was in application, we had a lot of problems with the steam engine explosion. So essentially, we anticipate that accidents will happen on autonomous ships. And the accidents will stem mostly from the uncertainty that is associated with the new technologies. Since we know so little about autonomous ships, we cannot predict everything and we cannot tackle everything. Some specific areas are related to the safe and ethical autonomous decision-making. This is a very intricate area which requires a lot of research before we can be sure that the autonomous collision avoidance on ships is safe enough. The use of big data analytics is also a potential sort of hazard because we can see that the neural networks, they behave in a very unpredictable manner sometimes. And using this technology in safety critical applications, so like autonomous ships, is something that is not very prudent, in my opinion. Remote control center functionality. This is something that is heavily discussed and is considered as a control measure against safety risks. So essentially, the seafarers will be located somewhere on the shore and they will be controlling using some joysticks the ships which will be thousands of miles away. But still, there are many uncertainties with how efficient and safe such a control system will be. The increased interconnectivity will render the autonomous ships a very lucrative target for cyber attacks, and this will be another area of concerns. Complexity is already present on ships because these are systems which very large in size and consisting from many components, but in autonomous ships, it will become even larger. And last but not least, the ships are assets of great value and they're expected to operate for a very long period of time. Usually, the typical life of a vessel is something like 25 years, and many things can happen in 25 years. And this practically means that we cannot simply predict that our ship will be fit for a purpose which will be defined maybe 10 years later or 15 years later. And it's important to highlight that autonomous doesn't mean necessarily unmanned, because we can have a coexistence of autonomous technology with unmanned technology. Now coming more to the different key enabling technologies, the challenges that we have are associated with the situation awareness system, because we need to specify very clearly and comprehensively what are the type of objects that needs to be recognized on the autonomous ships. Development of collision avoidance algorithms, that's a very interesting topic of research from safety perspective. And remote control center, that's another very critical technology, which needs a very robust safety assurance, and propulsion system, which always remains in place. But if we want to have a safe propulsion in case of unmanned vessel, then we will need definitely some sort of increased resilience or increased redundancy, which means practically more cost. And these extra measures will be also required when it comes to the use of remote control center. And currently, the cost of communication is very expensive. So paying 20 euros for 1 megabyte of data, that's something that will make any ship operating company bankrupt. If this ship operating company uses autonomous ships. So that's a very special challenge that needs to be addressed. A very interesting perspective can be taken if we consider the risks in a very large container ships. Usually this type of vessels, they carry a lot of cargo, and the cargo that they carry and the value of the ship can be something altogether more than 1 billion euros in net value. So in case of complete loss, that means that we are having something like 100k euros expected risk value. However, this is based on the consider statistic of complete loss. But if we consider the fire risks, we have a much larger expected risk value. In case of an unmanned vessel, if there is no crew present, then probably a fire that starts will cause a significant damage. So it practically means that if we consider the cost of the crew and the cost of potential damage, that might be better to have the crew on board the ship as a safety measure against some very big hazards that can occur. But of course, this is just some ideas. And the reason behind is that essentially people are very good at remedying accidental scenarios. Many people claim that a lot of accidents in the maritime happen due to the human error. Well, this is true, but if we dig deeper, we will see that also many accidents are prevented by a prudent human intervention. And this will not be present on unmanned ships. And as a result, then probably we will have more loss of cargo and more accidents finally happening if there are no humans to intervene and to control some of the hazards. So, and if you have read this very nice book, then you will understand much better what has been explained here. And lastly, but not least, if we have accidents on autonomous ships, then probably we have some sort of backslash. And in case of autonomous cars, this has been already happened. So people are much more skeptical nowadays about the use of autonomous cars than they have been previously. In maritime, that's not so of a big issue, since people sailing on ships, they usually pay for that. So they are ready to accept the risk for their own financial benefit, but still it can constitute an extra obstacle to the introduction of autonomous ships. So how can we address them? How can we facilitate the introduction of autonomous ships in the maritime industry? Well, there is no simple way. Potentially, we could exploit some robust approaches to safety assurance, and there have been a lot of research ongoing in that area. So we have developed an auto-ship project, suggested frameworks. There is a cross-domain approach developed by University of Warwick, which combines expertise from maritime, aviation, and automotive industries. We have also goal-based standards in the maritimes, and we work on how to enhance them. And use of advanced safety methods, it can also facilitate the identification of hazardous scenarios. So all this can be used in order to reduce the uncertainty and increase our knowledge of potential hazardous scenarios in the systems. I would also advocate for a gradual approach to introducing autonomous ship systems. There is a very interesting example of how things can go wrong if we try to do a lot of innovation just in one project. So you can see this very nice ship. It looks very beautiful, but in terms of project management, it's a complete failure. So initially, the American Navy wanted to buy 32 of the ships. Finally, 3 were constructed and only 2 are in operation nowadays. And the reason is that they wanted to implement a lot of novel technologies just in a single case. But as a result, these ships did not manage to meet any of the functional requirements which were set at the beginning of the project. And I would say that even the ships are not completely safe. I remember during our some studies I did at NTUA, National Technical University of Athens, our professor was commenting that this type of ship most probably will not survive an encounter with giant waves, which currently can happen at any random time in the ocean. So if the ships encounter a 25-meter wave, it will just submerge and will never emerge to the surface, because the nose of the ship, the bow, is designed in such a fashion that it will not allow it to have good sea performance capabilities. Yara Birkeland, that's another example. It's an example of an autonomous vessel which is currently in operation in Norway. But some rumors, they say that the initial cost estimation has been exceeded 10 times. So it's also a failure in terms of project management, but okay, Norwegian probably can afford that. So that's why the best way is just to try to eat the pie piece by piece by trying to solve small problems and in this way to propel the advancement of autonomous technology. It practically means testing the technology, most probably in demand context, with small research and data acquisition vessels, in safe and rescue vessels like firefighting tugboats. With some military applications, unfortunately, people are very good when it comes at killing each other, and in simple environments. We can also advance the introduction of autonomous ships if we reduce the operations to the open oceans. We have very little ship encounters in the open ocean, and that's somewhere that autonomous ships could be easily implemented. And last but not least, we could consider the new approaches to design or consider novel systems in the context of autonomous ships. Probably we could use fuel cells, which are automatically redundant, condition monitoring solutions, redundant systems, but with some degradation in the requirements. So instead of having one propulsion engine for the ship, we could have two, but with the half of capacity each. We could relax the damage stability requirements for unmanned cases of autonomous ships. We could relocate the air pipes and change the ventilation. And we could also prioritize the different types of communication. So there's a lot of innovation which could happen and could facilitate the advancement of autonomous ships. And we could also consider new design tools based on AI in order to explore different design alternatives. So concluding, I'm still optimistic about the autonomous ships. Some people believe that I'm like Cassandra, but it's not really the case. So I'm designing an autonomous ship myself together with another researcher from Aalto University. And I also believe that it will happen faster probably than in car industry. But still, I would not hide that there are huge uncertainties and complexities in design, and this can lead to increased costs due to safety concerns.
1 minute, Mr. Bolbot.
That's why I believe we need to follow a step-by-step approach to the introduction of autonomous ships. So that's all from my side, and I will be available for question later on. Thank you very much for your attention.
Thank you, Mr. Bolbot. Sorry for the interruption. Very interesting aspect, a very important aspect of introducing new technologies, this marine with shipping. And for Greece, for countries like Greece, we have a lot of marine technology that's very important. So we'll have a question at the end of the session. Let's move on to the next speaker, who is Mr. Floridis. Mr. Floridis is Mr. George Floridis has studied mechanical engineering in the Aachen in Germany, and he received his master's degree as a diploma engineer. Sorry for if I don't pronounce it correctly, with specialization in energy technology. He has also followed a postgraduate study in energy and environmental management at the Technical University of Berlin and in 2013, he obtained his Master's of Business Administration from MBA from the University of Cyprus. George Floridis has an experience as project maintenance engineer in the Mechanical Engineering Department of the Vasilikos Cement Works, and since 1993 holds the position of the Health and Safety Officer at the Electricity Authority of Cyprus. He's a member of the Technical Chamber of Cyprus and charter member of IOSH. He's a former president of the Cyprus Safety and Health Association and currently a member of this professional body, sharing his expertise with the new board members. He will talk to us about applying your RAM software to ease risk management. Mr. Floridis, the floor is yours.
Thank you for the introduction. Let me share my thank you for the introduction. Dear colleagues, good evening. First of all, I would like to thank the organizer of the 15th Safety Gala, especially the management force, for the kind invitation. The topic of my presentation is the application of software which helps to manage effectively the hazards and risks in large organizations. Through my presentation, I will try to capture the overall picture of the health and safety issues, covering a wide spectrum of activities in the Electricity Authority of Cyprus. As for the outline of my presentation, I will briefly give an introductory information about the Electricity Authority of Cyprus and additional updates on the current working environment, focusing on the health and safety issues. I will then explain the complexity of the work, the Electricity Authority, and the risk assessment procedure, followed by using a specific software. Moreover, I will go through the benefits from the procedure and how the software works as an efficient tool for managing hazards and risks at the workplace. So briefly, the Electricity Authority of Cyprus is an independent public corporate organization established under the Electricity Development Law in 1952 in order to exercise and perform functions relating to the generation, transmission, distribution, and supply of electric energy all over the island of Cyprus. The vision of the organization is to ensure the highest quality of safe and reliable services in the energy sector and in other activities, of course, respecting at the same time the environment and the society and contributing to the development and welfare of the country. Currently, EAC runs 2 power plants using, for the moment, conventional fuels, with a total installed capacity of 1,478 megawatts, as well as 2 photovoltaic parks of total capacity of 15 megawatts, and some others being under construction. It also operates a desalination plant, producing potable water of high quality of total capacity of 60,000 cubic meters per day. So the generation unit of the Electricity Authority of Cyprus is responsible for all tasks related to the construction, maintenance, operation of power plants, as well as for the design and development of the generation system. The major hazards in the power plants arise from the operation of high pressure and high temperature equipment, such as steam and gas turbines, large boilers, electrostatic precipitators, auxiliary equipment, etc. Working at height, working at the high, close or near to high voltage equipment, and various day-to-day construction and maintenance works. The continuous effort to improve efficiency and reduce production costs requires the promotion of new technologies, materials, and methods of maintenance and operation in order to achieve these targets. The planning of using natural gas in the near future as a primary energy is a new challenge for the Health and Safety Department, and the introduction of new risk assessment procedures is necessary so that we can meet the current requirements. In the network unit, however, we are operating in an environment where multiple phased and complex risks exist, such as working with or close to power lines and equipment, even close to high voltage power lines, as you see here in the pictures, working at height on a daily basis and often under extreme weather conditions in winter and in summer. You know that the weather in summer in Cyprus is very hot in the summer. Handling large scale projects for the development and maintenance of the existing network, installing heavy underground cables for expanding the underground network, which includes high-risk operations, carry out works in substations where high voltage equipment are in operation. So the management of the above mentioned activities, which involve high risks, is inevitable, a challenging task, as the commitment of the Electricity Authority is to provide a continuous and uninterrupted electricity for industry and households, and there is no place for any unsafe conditions. In addition to this, there is also the maintenance schedule in distribution substations. Note here that we have more than 12,000 distribution substations all over the island, where our personnel or subcontractors need to carry out the work safely without interrupting the power supply. Our staffs in this case are exposed to equipment which are alive, and special precautions and permits to works methods are strictly applied. In the distribution substations, we have equipment in operation, such as the distribution board. In many cases, this distribution board is of the open type. That means we are directly exposed to the electricity hazard. Exposed to cables after excavation for any repair and maintenance, transformers, circuit breakers, etc. The works here involve construction of new channels, repair and reinforcement of the structure of the building, demolition of walls, replacement of the roof in some cases, removal installation of doors and windows, and so on. So the Cyprus law, the Cyprus legislation requires that every employer has to develop a health and safety management system to control the hazards and risk, and to have a written risk assessment for each activity and workplace. The Electricity Authority has developed and implements since 2010 an effective and appropriate health and safety management system, which enable us to monitor all activities so that the continuous development and configuration based on the requirements of the legislation is achieved, and include all written risk assessment for all activities and workplaces. As briefly mentioned above, the Electricity Authority, in the Electricity Authority, we have to deal not only with a large number and variety of activities, but also with specific tasks bearing a high degree of risk and complexity. In an attempt to manage the hazards, we have grouped and categorized the tasks, more than 500 tasks, which would be continuously monitored and reviewed periodically in a productive and an efficient way. Therefore, the use of an appropriate software tool to manage, monitor, and easily review risk assessment is an essential task for the organization. A risk assessment software helps to develop a configurable methodology and risk assessment workflows to systematically identify, evaluate, and eliminate risks and hazards within the organization. This gives to the organization a complete picture, a global picture of the occupational related risks, and helps the health and safety department to standardize and the recording of risk assessment data, and ensure that proper tracking and controls are used consistently. Certainly, each organization sets its own requirements and needs for the software. For this purpose, the Electricity Authority has chosen to implement the software tool developed by the management force, as this satisfies the requirements of the organization, such as supporting the Greek language, for example, be user-friendly and understandable to the staff, to comply with the Cyprus legislation, to be easily integrated in the intranet of the organization. And important also is to be adaptable and expandable to the needs of the organization activities, since we have special needs and special activities to cover, to be easily retrieve easily already existing informations, to export reports for quick risk assessment control of the hazards, of the measures, of the people exposed, of the risk evaluation, and to export reports on pending actions and monitor the implementation of the risk assessment procedures. The selected software support also the quantitative methodology for the assessment of hazards, using the 5 to 5 matrix to rate the risk level, combination of the severity and likelihood. The risk matrix helps to quantify the risk identified by each hazard based on their severity and probability, and therefore we can prioritize the risks according to their potential impact and likelihood. So let's move to the software features we use to monitor and manage the risk assessments in the organization. In the following slides, I will briefly present the implementation of the software for managing the occupational hazards and risks in the Electricity Authority. At this point, I would like to apologize in advance for the fact that the content in the description is in Greek, while the program instructions here are in English. You have noticed on the picture here. This is due to the fact that I have used the existing data from the program we are implementing at the Electricity Authority, and the information has been entered in Greek language. Of course, the information can be also imported directly in English if we wish so. So for the purpose of this project, the organization has been divided in 3 levels to serve the organizational structure of the risk assessment. In level 1, the system, which is the upper level, the system consisted from the head office, the headquarters of the organization, the generation and units, and the transmission and distribution unit, which are the main departments of the organization. In level 2, we have the subsystem, which includes the individual power stations and the 4 district areas or district office following the structure of the Electricity Authority. Note that the Electricity Authority is split in 4 district areas according to the island's needs. And in the level 3, we have the section. We have that includes all department of each power station and of each district area, under of which section we have the corresponding risk assessments of the various tasks following again the structure of the organization. So this is how we design the structure for the risk assessment program. An important feature of the software is the generation of reports to review the hazards and hazards factors and the implementation of the measures, as well as other related information. This enables us to have a comprehensive view of the risk and manage them effectively, particularly in large organizations such as the Electricity Authority, where there are large number of tasks and complex activities. The management of risks and measures to be implemented is made easier and more effective by using this software or any other software that could help to manage all these tasks. The database can be easily configured, as I said before, according to the requirements of the organization. And this gives us great flexibility to implement the risk assessment in complicated and difficult works. So in the following slides, I will present further features of the software that contribute to the effective management of the workplace risks. On these slides, we have additional capabilities of the software, as I said, for the overall management of risk assessment studies. In the first report, the picture on the top of the slide, we have an overview of the risk levels, review dates, measures taken, responsible persons, etc. for each task. And in the second picture below, we see the report showing the hazards and hazards factors for the operation in each system, subsystem, and section, as I explained before. This is useful for drafting guidelines and policies to be implemented through the health and safety management system. And these reports can be easily exported in either in Word, Excel, or PDF format. This helps us to make the policy for the health and safety management system, to group all the problems and the hazards, and make policies and issue internal directives for our personnel or guidelines to our staff. Here we have another two examples. So the image on the top of the slide shows the report view of the risk control and implementation measures for each task at the department level, or the measures that need to be implemented. So we have an overview of what we have to do, and we can then make our plans accordingly. Similarly, the image at the bottom shows information about the risk assessment rating before and after additional safety measures have been taken. This enables us to have an overview of the risk factors globally in the whole organization by having reports with all these informations. Both reports contribute to the effective implementation, again, of the health and safety management system. And this enables us, as I said, to have a global control of the occupational risk levels in the organization. So in the next 5 slides, I will present a detailed example of a risk assessment report. In the first page of the risk assessment report of a certain task, we have the general outline of the task with all necessary information, such as subsystem, system, subsystem, the section, the revision number, and date, revision date, the overall risk rating of the task, who is responsible for this task, and when this should be the next revision proceed. A detailed description of the working environment in general, which is also in the second page, where we have again the information regarding the working environment conditions and the implemented measures of the work where we are rating and make the risk assessment. And following this, we have now the next 3 slides where we analyze the hazards related to the task and rating the risk. In the first column, or the color column, we have the rating of the risk before taking any additional measures. And in the last column, we have
1 minute, Mr. Floridis.
Thank you. we have the final risk after implementing further protective measures. The overall number of hazards depends on the complexity of the task, and we have we have to analyze. And as you can notice, the risk rating is colored accordingly to the level of the risk, and the color is in line with the 5 to 5 matrix I have previously introduced. This is my last slide. Thank you for your attention, and then question and further discussion on this matter is welcome. Thank you very much.
Thank you very much, Mr. Floridis. It's always very important to share the experience of successfully implemented technologies in organization operations. So that was very nice from you too. I think that we have about a minute left. Let's start with questions. So let's start with Mr. Kouderis. We have a question on. I am interested how you deal with the signatures of the permit by the user. I mean, in our experience, always the authorities seek for a wet signatures on the permit, and they require it on paper. Don't have to read the rest of the question. So, Mr. Kouderis.
Yeah, thank you for that question. It's something that also TAPCON's considering that, of course, and assessed it also with our legal department. So, first of all, as we mentioned, personnel are registered in Agora, and then are registered also in Mogo. Each user is registered and is generated a unique account, and credentials, of course, of this account are private. And as a final result of that process is that each user has a unique digital signature in the system. Finally, because the point was regarding the ink signatures, for every activity that is connected with a permit to work, a toolbox talk or a dynamic risk assessment is performed, on which the ink signatures are kept as well, which means that we have the permit to work system in place, and then on site every day the team needs to sign the dynamic risk assessment or the toolbox talk, should complete and sign the dynamic risk assessment or the toolbox talk. With that way, we have also ink signatures, except all the other process that it has been followed electronically. I hope that I have answered the question.
Thank you, Mr. Kouderis. I guess that this question has to do with this answer has to so many questions. I have been asked so many times about this topic. So it's very important that we know how a big organization like yours how they address this issue. Thank you. So, Mr. Bolbot, I hope I pronounced your surname correctly. There is a point here that as an ex-seagoing engineer, it has long been opinion that the ship's crew will be reduced to beat danger, sentinels, and firefighters, as all operations and troubleshooting will be carried out remotely. What is your opinion?
Thank you for this very nice comment. Yes, there have been a lot of discussion on that topic, and several companies, they believe that all of the ship operation could be automated, so the ships could be fully unmanned. And I think this is something that Rolls-Royce pursued. But after a very long period of time, it's still something that we are waiting to see. So there were some very optimistic expectations with respect to introduction of autonomous ships, like that by 2020, there will be several prototypes, and by 2025, there will be fleets of autonomous ships. That's something that we don't see now. And this is one of the reasons. So essentially, the maintenance and the control of some safety hazards is simply not possible using the current technology, or it's too expensive. So it's just more financially prudent to use the crew in order to tackle some of the safety hazards. Essentially, the autonomous technology is good in some specific envelope of tasks. So an autonomous navigation system most probably will select a better navigation path and will much better dock a ship to appear. But in a situation where something goes wrong, then humans are much better at addressing these scenarios. So that's finally, I believe that we will have a convergence to some sort of integrated operation. So we will have a lot of functions automated, but still we will have people at the final decision point and available to intervene in case of unexpected or emergency situations.
Thank you, Mr. Bobo. Mr. Floridis, one question. Now that you have successfully implemented software solution for risk assessment, what could be next in your wish list in your organization? Have you identified any other areas of that actually really need to be digitized ever?
Well, it's interesting to the presentation here about the digitalized permit to work. As you know, we use the permit to work in extensively in the Electricity Authority of Cyprus, especially both in power stations and in the network to operate our equipment, because we are dealing with electricity and it's high risk equipment. So I think it's something that we have to think about and digitalized work permits to be more efficient, especially in the substations, in the distribution substations, where we have also the contractors working there. But it's something that we have to discuss more extensively internally and see how we proceed to move more to this digitalization world that we are hearing today.
Thank you very much, Mr. Floridis, and thank you very much. Thank all three speakers for very interesting presentations. I think that the audience has earned something, has come to gain from watching all these three presentations. And so it's time to finish the session. And so we have a 10-minute break.
I think that there are a couple of questions that have not been answered, at least for
let's
very quickly. I can answer them and summarize what they have asked. The first one was regarding the permit to work. When we are issuing a permit to work through the MOGO, if it requires a new risk assessment or method statement. No, it requires this to be reviewed, not a new one, but the system is forcing you to check as a prerequisite before issuing the permit if this has been checked, the risk assessment and method statement. And regarding the topic for the conflict, the CMOPs, if this is defined by the location, it is based on the location. So for each permit to work, the user selects an area of effect. If another user tries to put in this area of effect another permit to work, the system will warn the issuing authority for potential CMOPs. The same applies for the isolation point and for isolations and for equipment. And regarding the stats and the show time again for all these HSE procedures, TAP is a lean organization, and without an electronic permit to work, it would be difficult to implement it. So that is why we chose electronic permit to work from the beginning, one of the reasons, and of course for the benefits that it's giving. So from these several improvement workshops that we have done and the 21 improvement points, we have achieved to reduce 33 man-hours per month, considering again the organization of TAP and the manpower that it has. And we have not have any AI functions yet, but it is something that we are having in our agenda for future evaluation. That's it, and thank you.
Thank you, Mr. Kouderis. And there are a couple of more questions, but I think that we're exceeding our time. And the next session will be in 2:45, and the next session will be session 4, technological innovations to improve health and safety. So thank you for watching this, and we will explain you on the next session. Thank you. Bye.